Welcome to another Back of the Net recording. This is for helping you with similar shapes and questions about finding the sides of similar shapes. Most of the ones we're going to do today will be on triangles, but it can be used in rectangles as well. Okay, again for me this is a topic where highlighting is really important. Using a highlighter in the exam can really make things a lot easier for you. And I'm going to tackle these particular questions by using equivalent fractions as well. Okay. The diagram shows two triangles. The triangles are similar. That's a crucial bit. It just means that one is an enlargement of the other. Calculate the value of A. Now this can seem really daunting and really quite difficult. Then I'm going to have to find the value of B on that one as well. And the way I like to do it, to simplify it, is to begin to highlight the corresponding sides of my similar triangles. So I get my highlighter out. And I'm just going to refine it slightly for you, so it's about that thick. And let's just highlight one side first of all. I'm going to highlight this side in pink. The corresponding side on this one is there. The corresponding side to A will be this one that's 4. So I'm now going to do that yellow. Sorry, and do that yellow as well. And finally, my final side I'm going to do in green. So I've now sort of matched up which side goes with which. I've been asked to calculate the value of A. The first thing I'm going to do is write down some equivalent fractions about these sides. And I'm going to try and stick to doing that in pink and green in the same colours. You could just do this in the exam and highlight the bits if you like. Now I've said that, I'm going to change my mind and do it exactly as you would in the exam. So you can say that 2 over 5, that's the green, that's the little over the big, was in green. It's going to be equal to, well, let's do that was wrong, sorry, I'll undo that again. I should have, of course, highlighted that in pink. That's the pink sides done. It's going to be equal to the yellow sides, and the little one there is 4 divided by A. Let's just highlight that to be clear we meant the A ones. That's my A side done, and then finally it's going to be B divided by 8. And they're all going to be equal to each other because the ratios of those sides must be the same. That one was green, let's just put some green on there. I don't always actually colour this bit in the exam, but if you're struggling it does help. Okay, so 2 to 5 equals 4 to A equals B over 8. So I'm going to rewrite the 2 over 5 equals 4 over A. Now, just about everybody I teach is really good at equivalent fractions. What's equivalent to 2/5 for what? Well, I've times by 2 times the bottom by 2 is equal to 4/10. Therefore A must be equal to 10. Dead easy question that. Really quite straightforward. That's A done. We've now got to calculate the value of B. So let's go and try and work out B. What is B? Well, I'm going to have to put my B1 in. So this one here was B over 8. Is equal to, well, I've got choices now. I can either say it's 4 over 10. I've already worked out A. It may be safer to go with the question that was given to me, which is 2 over 5. I'm going to ignore that one in case I worked out the 10 incorrectly. I've got the facts that were given to me in the question. They were given to me as part of the question. The problem is I'm struggling to find equivalent fractions for those two there. I can't get from my 8 to my 5 easily. There's no easy number. Had this been 50, it'd be easy. I'd just be timesing by 10. What I'm going to do is pick a number that I know both are in, and that's 40. I can get fifths to 40s by timesing by 8, so times that by 8 will give me 16/40ths. So that's another pattern in my sequence. What's nice about that now is if I write an 8 there, how do I get from 40 to 8? I divide by 5. So I've got to do 16 divided by 5. I'm just going to write 16 divided by 5 there for the moment. That's the answer I want, that's what B is. So B equals 16 divided by 5, change it to a fraction. How many 5s in 16? 3, and 1 left over. So the answer is 3 1/5. So B will be equal to 3 1/5. That last bit there about having to do these equivalent fractions does make this question a lot tougher. It's one of the toughest one of these I've seen. I've shown you that and I hope you can see how you may be able to use your equivalent fractions for ones you haven't been given in the question. Come up with another equivalent fraction of your own that helps you get there. Don't worry too much if you couldn't do with that. Let's move on to the next question. This isn't a triangle one, but you can use the same techniques. I'll let you press pause now. Okay, welcome back. I'm going to go through these ones with you. Let's see how you manage on this. The first thing I'm going to do is just get in there straight away with my highlighters. Doesn't really matter which ones to do first. I'm going to make that one pink, so that one's pink. Let's make the bottom one yellow, so that one's yellow. Let's make the top one green, so that side's my green side, that's my green, and let's make this right hand edge orange, so that's orange. So I now know what side goes with what. Okay, first of all, find the length PQ. PQ. So that's my pinks. So I need to write down that 6 over, well, I'm going to call that side there x. Doesn't really matter what you call it, but a little over 6 over x has got to be equal to, that was my pink. Is there a side in here that links the two together where I've got both numbers? The yellow, I've only got one number in that diagram, I haven't got that one. The orange, I've got neither. The green, it's 10 over 15. Equals 10 over 15. Now that's not looking nice, there's no easy way to go through there. In the last question we had to go to 40 as it was quite a tricky one. In this one I would always urge you now, maybe write it a different colour pen, is just to simplify that fraction as much as you can. So 10/15 we can simplify to be, well, I can divide them both by 5, so that's 2/5. That may be an easier fraction to work with. I'm just going to rewrite now what I've got. I've got 6 over x has got to be equal to 2/5. Now this is nice and easy. To get to there I've had to times by 3, so I'm going to have to times by 3. 5 times 3 is 15, x equals 15. Not too tricky that one there. I've done that wrong. Doesn't seem right to me. I know exactly what I've done wrong. I could record, I won't record it, I'll show you. That should have been 3. I should have cancelled that to a 3, so it's 2/3. So that there would have been 2/3. 3 times 3 is 9. Sorry about that, that was a mistake. The reason I knew I wasn't happy with the 15 was to do with this 15 bit here. That was clearly longer in the picture than this one, so it couldn't have been the same length. It just didn't ring true with me, which is why I noticed I'd gone wrong. That was lucky, wasn't it? Do be careful when you're doing it. Always when you get your answer, have a look back and check, does that make sense? And just as I was doing, I was looking back and thinking, does that make sense? And I wasn't sure about it. Realised I must have gone wrong. Okay, next bit. Find the length AAD. I want to get A to D. I'm going to call that length Y. So Y divided by 12, it's the yellow bits. It's got to be equal to, well, I already know what it was. 2/3 was my simplest bit. 2 over 3. That's been times by 4. So that needs to be times by 4. 2 times 4 is 8. So AD is equal to 8 centimetres. Now 8 centimetres, that seems about right given the other shapes on there. I'm happy with that. Okay, so I made a mistake there. I'm sure you'll better see through that, and sometimes it's good to make a mistake so that you can see how you can go back and correct it. Okay, triangles ABC and PQR are mathematically similar. Okay, so we're back into similar triangles again. I'll let you have a go at this. Press pause now. Welcome back. Okay, usual thing I'm going to go for here. You should be getting the hang of this now. Let's just highlight the matching sides. Doesn't matter what colour you highlight them, but I do think highlighting the sides just let you just see it all a little bit more clearly. There we go. Right, so the key bit of information here is going to come from my yellows, because 4 over 6 links the two triangles together. I know what proportion they are to each other. Right, there we go. Right, part A, work out the length of QR. QR, there's this one here, I've got length X. So, 4 over 6, little over big, has got to be equal to 12 over X. Nice and easy. 4 times 3 is 12, 6 times 3 is 18. So X will be equal to 18. I just really ought to write that QR will also be equal to 18 centimeters. The next bit, work out the length of AB. Got to find AB. I'm going to call that Y just for ease. So Y divided by 15 has got to be equal to, well, 4 over 6. Now looking at that, there's no nice match between those two. However, 4/6, same as 2/3. Now it's easy. To get from there to there, I'm timesing by 5. So to get from there to there, times by 5. 2 times 5 is 10. So Y equals 10. So, what was that? That was AB. Okay. That's it for similar shapes, similar triangles, similar quads. Hope that's been useful to you. You can replay it. Do the highlighting. I know I don't use it effectively all the time, but it does let your brain see the pattern between the different ones. And your brain often is noticing things you don't even realise it's noticing, and this colour coding really does help with that. Okay, again, hope that's useful to you. Do come back for another BACnet recording.